So let me now pass to a second set of adversaries of the scientific worldview, namely the advocates of pseudoscience. Now, this is, of course, an enormous area, so I want to focus on one socially important aspect of it, namely so-called complementary and alternative therapies in health and medicine. Now, it was recently reported that the British government will be introducing standards of competence in homeopathy, aromatherapy, reflexology, and other alternative therapies in order to protect the public from inadequately trained practitioners. Now, that sounds nice at first glance, but what precisely does it mean to be competent in a system of pseudomedicine that has never been demonstrated to be efficacious beyond the placebo effect? Perhaps for its next act, the National Health Service will introduce bloodletting and trepanation, duly guaranteed by rigorous standards of competence for practitioners. Now, it's worth looking in a bit of detail at one of the most widely used alternative therapies, namely homeopathy, because its advocates sometimes claim that there is evidence from meta-analyses of clinical trials that homeopathy works. Now, one basic principle in all of science is GIGO. Garbage in, garbage out. And this principle is particularly important in statistical meta-analysis, because if you have a bunch of methodologically poor studies, each with small sample size, and then subject them to meta-analysis, what can happen is that the systematic biases in each study, if they mostly point in the same direction, can reach statistical significance when the studies are pooled. And this possibility is particularly relevant here because meta-analyses of homeopathy invariably find an inverse correlation between the methodological quality of the study and the observed effectiveness of homeopathy. That is to say, the sloppiest studies find the strongest evidence in favor of homeopathy. When one restricts attention only to methodologically sound studies, that is, those that include adequate randomization and double blinding, predefined outcome measures, clear accounting for dropouts, then the meta-analyses find no statistically significant effect, whether positive or negative, of homeopathy compared to placebo. But the lack of convincing statistical evidence for the efficacy of homeopathy is not, in fact, the main reason why I and other scientists are skeptical, to put it mildly, about homeopathy. And it's worth taking a few moments to explain this main reason. Most people, probably even most users of homeopathic remedies, don't clearly understand what homeopathy is. They probably think of it as a species of herbal medicine. Now, of course, plants contain a wide variety of substances, some of which can be biologically active, with either beneficial or harmful consequences, as Socrates learned. But homeopathic remedies, by contrast, are pure water and starch. The alleged active ingredient is so highly diluted that in most cases not a single molecule remains in the final product. And so the fundamental reason for rejecting homeopathy is that there is no plausible mechanism by which homeopathy could possibly work unless one rejects everything that we've learned over the last 200 years about physics and chemistry. Namely, that matter is made of atoms, and that the properties of matter, including its chemical and biological effects, depend on its atomic structure. There's simply no way that an absent ingredient could have a therapeutic effect. High-quality clinical trials find no difference between homeopathy and placebo because homeopathic remedies are placebos. Now, the advocates of homeopathy sometimes respond to this argument by asserting that the curative effect of homeopathic remedies arises from a memory of the vanished active ingredient that is somehow retained by the water in which it was dissolved. And then remember that the water is then boiled away. So then by the starch after the water is evaporated. But the difficulty, once again, is not simply the lack of any reliable experimental evidence for such a memory of water. Rather, the problem is that the existence of such a phenomenon would contradict well-tested science, in this case, the statistical mechanics of fluids. The molecules of any liquid are constantly being bumped by other molecules, what physicists call thermal fluctuations, so that they quickly lose any memory of their past configuration. And when I say quickly, I'm talking picoseconds, not months. So in short, all the millions of experiments confirming modern physics and chemistry also constitute powerful evidence against homeopathy. For this reason, the flaw in the justification of homeopathy is not merely the lack of statistical evidence showing the efficacy of homeopathic remedies over placebo at the 95% or 99% confidence level. Even a clinical trial at the 99.9% confidence level would not begin to compete with all the evidence in favor of modern physics and chemistry. Extraordinary claims require extraordinary evidence. And in the unlikely event that such convincing evidence is ever forthcoming, the person who provides it will assuredly win a triple Nobel Prize in physics, chemistry, and biology, beating out Marie Curie, who won only 2. Despite the utter scientific implausibility of homeopathy, the British National Health Service actively promotes homeopathy on its website and provides homeopathic treatment, so-called treatment, at the taxpayer's expense. There are 5 homeopathic hospitals in Britain, 4 of which are funded by NHS money. Alas, no one, not even the health minister, seems to know how much the National Health Service spends annually on unproven or disproven complementary and alternative therapies because they don't bother to keep track. But estimates range from anywhere from 50 million to 450 million pounds a year, probably towards the lower end of that scale. Now, granted, that's a tiny fraction of the 92 billion pound annual NHS budget, but it's still money that could give thousands of cancer patients provably effective therapies that are now denied for cost reasons.